Okay, so welcome guys to today's lesson. We continue solving tutorial sheet 3 in math. Okay, so last time we met, we were looking at question 1. Okay, we solved all these questions here. Okay, and then I remember even before this tutorial sheet came out, okay, I made a video where I was solving questions on using the factorization method, the completing the square method, and the quadratic formula, okay? Solving quadratic equations. I remember I made that video, okay? So you can find this video and the video for question 1 on my YouTube channel, Tutor Solutions, or you can find them on Drive, okay? So I'm going to start from question number 3. Of course, it has a similar concept of completing the square, but let's look at it. Okay, so question 3 here, they're saying write the following in the form A, open bracket, x plus b squared, and then plus c. So they're saying where a, b, and c are constants, okay? So in short, what they want you to do here, they just want you to complete the square on this guy here, okay? So this is how it's done. So let's do some of them. We're not going to do all, but let's do some of them. So let's look at the first one there. Okay, so the first one there we have A, we have f of x is equals to x squared, okay, minus 2mx, and then plus n. So we're being asked to express this expression in the form A, x plus b squared, and then plus c. So we are simply completing the square, okay, on this guy here. So the first thing, if you remember from the previous lesson, I said when you are completing the square, make sure that the coefficient of this x squared here is always a positive 1. Okay, so you check that. So we check here and we see that indeed it's a positive 1. So that condition is satisfied. We can proceed to the next one. So what is the next one? The next one is to form what we call as a perfect square, okay? So how do we form that perfect square? We write the equation the way it is, first of all, ending up to the term that has the x like that, okay? And then we say plus, okay? And then we're going to open the brackets. And then in these brackets, we're going to put half of the coefficient of x squared, of this x, I mean, okay? Half of this coefficient of x, okay, and then you square it. So meaning you get the coefficient of x divided by 2 and then you square it. So what is the coefficient of x in this case? It is this minus 2m. Okay, this is the coefficient of x. So we're going to say 2m divided by 2 and then what? Squared. Okay, remember we're creating a special zero. So what do we do from here? We write minus and then we write the same thing. Okay, we write the same thing that we've written here. So 2m, then over 2, and then what? Squared, and then finally plus n. Okay, so you realize that what we've done here is that we have created what we call as a special zero. Okay, so this part here is a special zero, but because you see that it's the same but with different sign. So meaning when we add them, we get a 0, right? Okay, so this special zero, okay, make sure that it makes it possible for these 3 terms here, okay, these terms here, to form what we call as a perfect square. Okay, so a perfect square, it means we can rewrite this as, okay, we're just going to get x here without this squared. We're going to say x, and then we're going to get whatever is in these brackets here. Okay, so whatever is in this bracket is what is minus 2m divided by 2, which will just be minus m, right? Because we are dividing by 2 here. So the 2 goes, 2 goes. We are just remaining with minus m inside the bracket. So we are going to say minus m here. Okay, then we are going to put these 2 in brackets, and then we are going to say square. Okay, so this term here that I've written, guys, is equivalent to whatever is here. So I know some of you have questions like, where is this guy going here? So we simply ignore this guy. Okay, you ignore this guy, you just get the x. Okay, you just focus on the terms that have a square like that. Okay, so you get the x, then you get whatever is inside these brackets, and then you put them in brackets and then square them. Okay, and then now you say minus, this minus here, And then what we'll have inside here, okay, we'll have a minus m squared. So what is minus m squared? It is a positive m squared. Okay, so m, we're just going to write m squared here. So this m squared here has come from here. Okay, and then plus n. Okay, so we see that this guy there is indeed in the form that they wanted. Okay, so we can write this is equals to x minus m squared, and then minus m squared plus n. So remember the form that they wanted. They wanted a x, okay, plus x plus b squared outside, okay, and then they said plus c. So in this case, we can see that the a there is just 1, okay? The a is just 1, so the coefficient that is here, so it's 1, the a, and then this b here is this minus m, okay? And then this c here is whatever you have outside, okay? Because this will be a constant like that. All right, so let's look at another example in the same question. We had b, okay? We had 2x squared, okay, plus 8x, and then plus 10. So we want to express this guy in that form, right? So it simply means we are completing the square. So what are we going to do? The first thing is always to make sure that the coefficient of this guy is what? 1, positive 1. Okay. So we're simply going to factorize the 2 here. So f of x is equals to 2. Okay. So I'm factorizing 2 from all these terms here. Okay. So if I get a 2 from here, I'm going to remain with x squared. If I get a 2 from here, I'm going to remain with what? 4x, right? And if I get a 2 from here, okay, I factorize a 2, I'm going to get plus 5. Okay, so make sure that whatever you have here, when you multiply by these 2, it gives you back whatever you have on top there. Okay, so you can see 2 multiplied by this, it gives me that. 2 multiplied by this gives me that. 2 multiplied by this gives me that. Okay, and then now we can see that whatever we have in the brackets here, we can now complete the square on that guy. Because why? The coefficient of this x squared here is now positive 1. So we are going to say this is equals to 2 outside, and then let's complete the square on what we have in the brackets. So we are going to create a special 0 here so that we can form a perfect square. So you write it the way it is, up to the term with the x, and then you say plus, okay? The coefficient of x, which is 4, divided by 2, and then squared, then minus, okay, 4 over 2, and then squared. So the same thing, you just write it twice with different signs. And then you can say plus 5 now. And then this should be in the brackets like that. Okay. So we see now from here that the first 3 terms here are going to form a perfect square. So we ignore this 4x there. Okay. So we write 2. And then let's ignore this guy here, the 4x. We ignore it. We just get x from this. Okay. And then we get whatever is in the brackets here, which will just be a plus 2. Okay. And then we can say squared, and then minus. So what we have inside here is a 2, and then 2 squared will just be what? 4. So you write 4 here, and then plus 5 across the brackets. Okay. So from here, let's simplify. You're going to have x plus 2, okay, squared, and then here to be minus 4 plus 5, which will just be plus 1, and then this. Okay. All right, and then from here, it will be 2x plus 2 squared plus 2. Okay, so what have I done here? I've multiplied this 2 with this guy to get 2 of this, and then 2 multiplied by this one to get 2. So you can see that this is indeed the form that they wanted, which is a x plus b, okay, squared, and then plus what? C. So you can see that the A is 2, B is 2, even the C is 2. So this is a good question, right? Very nice question. Okay, and then from here, let's look at another question. Okay, so let's continue, okay? So it means we've solved this one and this one, okay? So you can follow the same procedure also to solve this one and that one, okay? Let's look at question 4, okay? We sketch one of these. Okay, so let's sketch, I think G looks complicated with the negative signs. Okay, let's sketch this guy here. Okay, let's sketch this guy. So, okay, so G, is that D? Okay, so what is the question saying first of all? They're saying sketch the graph of the following quadratic functions, okay, showing clearly the x-intercepts, the y-intercepts, and the turning point. Okay, so the y-intercept, these are just the points where the graph cuts the y-axis. The x-intercepts are the points where the graph cuts the x-intercept. And then the turning point is where the graph turns, right? Okay. And then the question continues, they're saying state the line of symmetry. So the line of symmetry is just the x-coordinate of the turning point, okay? And then two, they're saying the maximum or the minimum value. So the maximum or the minimum value is the y coordinate of the turning point. Okay? So the x-coordinate of the turning point is known as the line of symmetry. And then the y-coordinate of the turning point, if you have a maximum turning point, it will be the maximum value. If you have a minimum turning point, it will be the minimum value. Okay, so let's get one of these functions and sketch it. So let's get C here. Okay, so C, let's solve it. Okay, so we are solving C on question 4, which is given by G of x is equals to minus x squared minus 5x, then minus 10. Okay, so how are we going to sketch this guy? Okay, we use completing the square method. Okay, because when you use completing the square method, it will be very easy for you to get the turning point and the turning point, the line of symmetry, and the maximum or the minimum value. It will be very easy. So I recommend that you use completing the square method. Okay, so it means we have to complete the square on this guy, right? Okay, so the first thing we said is to make sure that this x squared here is a positive 1 in front. So we can see a minus 1. So let's factorize the minus 1. And then what are we going to have? We're going to have x squared plus 5x, okay, and then plus 10. So let's complete the square now on this guy that we have inside. So this will be equals to minus 1, okay? And then this will be x squared. Remember, we're creating a special 0 plus 5x the way it is. And then we're going to say plus, okay? The coefficient of x divided by 2, and then we square it. So this will be 5 over 2, square it, and then minus the same thing, okay? 5 over 2 squared, okay? And then we say plus what? 10. So I've created a special 0 here, okay? And then this special 0 leads to a perfect square here, okay? So it means that what now? We are going to have our completed the square form like this. So we're going to ignore the term with the x, and then this guy here will just be the x. And then you get whatever you have inside here, which is plus 5 over 2, okay? Squared, then minus. So here we have 5 over 2, and then we square it. So you distribute the power to the 5 and to the 2. So what is 5 squared? 5 squared is simply 25 over what is 2 squared? It will just be 4. And then I have plus 10 here, okay? So you see that plus 10, I can also write it as 40 over 4. 40 over 4 is the same as 10, right? Okay, you can also write it like this. So why am I doing this? So that I can just easily add these fractions, okay? So if you want, you can do that. If you want, you can do that, okay? But for the sake of simplicity, I'll write the 40 over 4 there. So this will be x plus 5 over 2 squared, then minus, okay? Is it plus now? I think it will be plus because the 40 is big. So it will be minus 25 plus 40, which will just be 15. And then they will be over what? 4. Close the bracket. Okay, and then now you can multiply with your negative here. So if I multiply with a negative here, I'm going to have minus, okay, x plus 5 over 2 squared, then minus what? 15 over 4, like that. Okay, so this I've presented the function that we have now in the completed the square what form. Okay, I've presented the function that we had in the completed the square form. And then from there, what do we do next? Okay, we can find the turning point from this completed the square form. We can find the maximum value. We can find the line of symmetry. What will be left will be the x-intercept and the y-intercept, and then we'll be able to sketch the graph. Okay, so let's get the turning point here. So how do you get the turning point from the completed the square form? Okay, so you get whatever is in the brackets here, you equate it to 0, then you solve for x. That will be your x coordinate of the turning point, 0. Okay, so it means my x here will just be what? Minus 5 over what? 2. So this minus 5 over 2, it will be my x coordinate of the turning point. Okay, and then how do you get your y coordinate of the turning point? You simply get whatever you have here outside the brackets. Okay, so minus 15 over 4. That will be my y coordinate of the turning point. So we are going to say minus 15 here over 4. Okay, so we've gotten our turning points. Okay, let's get the line of symmetry now. Okay, so remember I said the line of symmetry is just the x coordinate of the what? Of the turning point. Okay, the line of symmetry is the x coordinate of the turning point. So you can say line of symmetry. I'll just write line of S here, which will be what? Minus 5 over 2. So this will be the line of symmetry, guys. And then is this guy a maximum or a maximum value or a minimum value? Okay, so we can't tell here. We first have to draw the graph. Okay, but to draw the graph, we need to find the x-intercept and the y-intercept. Okay, so where do you get your y-intercept? Okay, so your y-inter, you just get it from the very question that you have. Okay, y is equals to, and then you go to your question, you just get the constant here, which is the minus what? 10. So the y-intercept there will be minus 10, always. Okay, and then now let's try to find the x what? Intercept. So we know that we can find the x-intercept by equating whatever we have here to 0, and then we try to solve for x. Okay, so we have minus x plus 5 over 2 squared, and then minus 15. Okay, so this one here, minus 15, but if I equate this to 0 like that, it means I can get this minus 15 to the other side, right? So here I'm going to write is equals to 15 over what? 4. Okay, I can see a negative here. I divide both sides by a negative. Okay, if I divide by a negative 1 here, this negative will go. Okay, and then if I divide by a negative here, it will be minus like that. So we see now here that if I try to square root here, okay, for this square to go, this one and this one, okay, I'll remain with x plus 5 over 2. But on the right-hand side here, I'm going to say not equal to, because you can't find the square root of the what? A negative number. That would be a complex number, but here we're not dealing with complex numbers. Okay, so this simply means that this equation here, okay, does not have real solutions. Okay, it has no solutions, meaning it has no x-intercept. Okay, so it means just as a y-intercept touches the y somewhere, there's a turning point somewhere, but it doesn't touch the what? The x-axis. So since here it's negative and this here is a squared number, okay, we know that any number that you square like that, okay, any number that you square, it will always give you a what? A positive number. If you square a number, it will always give you a positive number. But here we see that if I square this, I get a negative. So meaning this is false. So you're going to say no solution or no x what? Intercept. Okay, no solution or no x-intercept. So it means you just need the turning point and the y-intercept to sketch this graph. Okay, so the turning point, let's write it here. Okay, the turning point was minus 5 over 2, then minus 15 over 4. And then the y-intercept was what? minus 10. Okay, so you can sketch this, guys. So you write your y-axis and your x-axis somewhere here. Let me do it properly. Okay, so this will be your x. So this is my x. This is my y. You can put your 0 in. Okay, so you can find the approximate values of this. So minus 5 over 2 is minus 2.5 somewhere there. Minus 2.5. And then this guy here, minus 15 divided by 4 will just be 3 point something, right? So minus 15 divided by 4, it is minus 3.75. Okay, so let's plot this. Okay, so I can have okay, so if this is minus 1, this is minus 2, okay, this is minus 3. It means my minus 2.5 is somewhere here, right? Oh, no, this is in the y-axis. So it means we are looking for this guy. But in the x, if this is my minus 1, minus 2, minus 3, okay? So between minus 3 here somewhere, that's why I have my minus 2.5. And then this minus 3.75, it will be somewhere after minus 3, right? So maybe somewhere here. That's where I'm going to have the turning point, okay? And then it means let's continue the graph like this. Somewhere there, I'm going to have the minus 10, which is the y-intercept, okay? So it means your graph is going to come like this. Okay, it turns there, then it comes like that. It passes through the y-intercept like that, okay? So this is the graph of x squared minus 5x minus 10. So this is the graph here. So we see that the turning point here is the maximum turning point, okay? So meaning that minus 3.7 something there was the maximum value. So here maximum value, it will be y is equals to minus 15 over 4, which is approximately minus 3.75, right? Okay, so that's how you sketch that one. I also sketched some more in the other video, so you can check them out. Yeah, you can check them out. Let's look at question number 5 now. So question number 5, they're saying, without solving the quadratic equations, determine the nature of the roots for each of the questions below. Okay, so determining the nature is not hard, guys. Okay, you just have to know your values of A, B, and C from the quadratic equation, and then you put them in the formula for the what? For the discriminant. Okay, so discriminant is actually equals to B squared minus what? 4AC. So where do you get this B, the A, and the C? You get it from the quadratic equation there. Okay, so depending on the value of the discriminant, okay, it will tell you the nature of the roots for the quadratic equation, okay? So if the discriminant is less than 0, then we conclude that there are no real roots for that equation, just like the one we are from solving, okay? If we took the discriminant of that guy, you see that it will be less than 0, okay? And then if the discriminant is greater than 0, it means you have real solutions. And then if the discriminant is equal to 0, it means you have 2 equal solutions, or you have just one solution, okay? 2 equal solutions or 1 solution if the discriminant is equal to 0. So let me write the conditions down for those that are taking that down, okay? So we are saying if the discriminant is greater than 0, then you have what? Real solutions. That's the nature of the solutions, okay? They will be real. You have 2 numbers that are real numbers. And then if the discriminant is equal to 0, we are saying we have what? 2, okay, real solutions, or you can just say 1 solution, okay? 1 solution like that. Okay, what if the discriminant is less than 0? Okay, we said if the discriminant is less than 0, then we have no real solution. Okay, no real solution. or some books, they say you have complex solution, okay? Or some books will say the graph does not touch the x-axis, meaning it does not x-intercept, okay? Just like the one from solving, okay? So make sure you know the language. They can say no solution, they can say complex roots, or they can say it does not touch the x-axis, okay? Or it has no x-intercept. It means the same thing. It means the discriminant there is just what? Less than 0. Okay, so they're saying determine the nature of the roots without solving the questions. So the first one that they gave us was this one here. It was x squared plus 3x, then minus 4 is equals to 0. Okay, so we can get our a, our b from this, right? So our a is what? We say our a is 1. Our b is 3. Then our c is what? Minus 4. Okay, and then from here, let's input this into the formula for the discriminant. So we know that the discriminant is equals to what? B squared minus 4ac. Okay, so this will be equals to b squared, which is 3 squared, minus 4, 1, and then minus 4, which is ac. Okay, so here we're going to get 9 from here, and then minus 4 multiplied by 1 multiplied by minus 4. Which will just be plus what? 16. So we see here that the discriminant is what? 25. So where can we fit this 25 as the value of discriminant in here? We see that 25 will be greater than what? 0. So it means the nature of the solutions there will be what? Real solutions. Okay. So since you can say since D is greater than 0, okay, the nature of the solutions will have real what? Solutions. So you can say 2 real solutions. Okay, so you say 2 real solutions. All right, and then the B, let's try to see what it will give us. The B, we had 2x squared is equals to 12x and then plus 54. So this is what we had there. Okay, this is what we had. So, I think this one is a minus. There we have 0. Okay, so this one is a minus here. It's not an equal sign. So here we have minus like that. Okay, so you get your A, which is 2, your B, which is what? Minus 12, and then your C, which will be 54. So let's input it into the formula for the discriminant. We see that we are going to have b squared, which is minus 12 squared, okay, minus 4a, which is 2, and then c, which is the 54. Okay, so let's multiply. So minus 12 squared, it will be 144, and then minus 4 multiplied by 2 multiplied by 52. What are you going to get? Okay, so that will give us 4 multiplied by 2 multiplied by 52. Going to get 432. Okay, then this 432 minus 144, it will give you a minus. Okay, it will give you a minus 288. So now here we see that our discriminant is what? Less than 0. So if the discriminant is less than 0, because it's a negative number, you say that no real solutions. That's the nature of the what? The roots. Okay, no real solutions. Okay, let's look at another example, which is the last one of this concept. I have, I'll get D. Okay, D I have minus x squared plus 6x. Okay, and then plus 18 is equals to 0. So let's get our A, which will be a minus 1, B will be a 6, and then C will be 18. So let's put this into the discriminant formula. You have D is equals to, just drop my phone. Okay. Okay, so discriminant is equals to B squared, which will be 6. Okay, Okay. B squared, which is 6 squared. Now my PC is not pressable. Okay, so just a minute. Okay, so as I was saying, you get the B, which is the 6 squared. Okay, and then you square it, and then you say -4. The 1 is the -1, and then you put your C, which is the 18. Okay, so you multiply here. What are you going to get? 6 squared would just be 36. Then here we have -4 multiplied by -1, which will be a +4. And then that +4 multiplied by 18. Okay, so 18 by 4 will just be 72. Okay, then this you can add them, you're going to get 108. So we see that the discriminant is what? Okay, the discriminant is greater than 0. So meaning we have 2 real what? Roots. Okay, we have 2 real roots. Okay, so we are done on that question. The other one you can try this and you can try that one. Okay, then let's look at question 6. Okay, so using the concept of the discriminant, okay, you can be given an unknown value in the quadratic equation, such as this P here, and then you can be asked to find it based on the nature of the roots that that quadratic equation has. So here they're saying determine the values of P for which the quadratic equation, this equation here, okay, has 1 real roots, no real roots, equal roots. Okay, so let's exhaust all those 3 conditions. Okay, so we solve that now. Okay, so let's solve that now. We have 2x squared plus px, okay? And then we have plus 8 is equals to 0. Okay, so we have been asked to find the values of p for this equation to have 1, okay? They're saying what? Real roots. So we know that if it has to have real roots, okay? Then we know that the discriminant there should be what? Should be greater than 0. Okay, if you want, you can put greater than or equal to, it's the same. So the discriminant should be greater than 0. Okay, so we know that the discriminant is b squared for ac. Okay, so let's get our a, our b, and our c from that equation there. Okay, so our a will just be 2, our b will just be p, okay, and then our c will just be what? 8. So let's place these into this formula, and then we say it's greater than 0, okay? Because here they are claiming that the roots are real, okay? So we are going to say b squared, which is just p squared minus 4a, which is 2, okay? And then c, which is 8. We're saying this here should be greater than what? 0. So let's find the value of p. So this will be p squared minus 4 multiplied by 2, it will be 8. 8 multiplied by 8, it will be 64. So you have 64 here, greater than 0. Okay, so we see that this guy here is the difference of 2 squared. So we can factorize this by saying this is p plus 8. Okay, and then the other one will be p minus what? 8. So this is the difference of 2 squared, a skill that you should know. Okay, so this one here has a perfect square, even this one has a perfect square. So you can separate them by just putting what? Different signs like that. When you expand this, you'll get back to this. Okay, so this is a difference of 2 square. And then what did I say when we have a greater than sign in a quadratic equation? Okay, I said the answer should be p should be greater than the greater number that you get here, and then p should be smaller than the smaller number that you get here. So you're going to equate these guys to 0 and then solve for p. So if you equate this and solve for p, you are going to get p is equals to what? 8, minus 8, I mean. And then if you equate this to 0, solve for p, p will be equals to what? 8. So this is what we have, okay? This is what we have. And then since it's an equality sign there, okay, we have to express our answers in the inequality sign. So we are going to say P, okay, is greater than the bigger number of these two. So which one is bigger here? It will be 8. And then you say, or P is less than the smaller number here, which is what? Minus 8. So if you didn't watch the other video when I was teaching the quadratic equation, make sure you watch them, okay? Okay, so these are our answers. P, okay, for that equation to have real roots, P should be greater than 8, or it should be less than minus 8. Okay, and then the other condition was what? The other condition was no real roots. Okay, so meaning whatever we have here should be less than what? 0. If it is no real root. So I get P squared minus 64. This should be less than what? 0. Because now we are considering a situation where the discriminant is less than 0. Okay, so again, we apply the difference of 2 squared, it will just be P minus 8. Okay, and then the other one to be P plus 8. Okay, less than 0. Okay, we saw that when I equate this to 0 and solve for P, to just be P 8, and then the other one to be P minus 8. So now, how do you express your answer if you have a less than? Okay, in the other one, you have a greater than. So if you have a less than, you're going to write the P in the middle, then you're going to write 2 less than sign. So you put the greater number here, then the smaller number here. So this here will be your answer. So if the P is between minus 8 and 8, you are going to have no solution for that quadratic equation. Okay. Then the third condition is that, okay, the discriminant is equals to 0. So meaning that the P squared minus 64 is equals to what? To 0. All right, so here we can say P squared is actually equals to 64, but we want to find the value of P, so you square root this side, you also square root this side, so P just be equals to, from the square root, you have your positive and your minus what? 8. So it's either the P is 8, okay, or the P is minus 8. So if you have either one of these, it means your discriminant will be what? Equals to 0, okay? So if the P is 8 or the P is minus 8, your discriminant is going to be equals to 0. If your P is between 8 and minus 8, you are not going to have any solution. And if your P is greater than 8 and your P is less than 8, then you are going to have what? Real solutions. Okay, so that's how you solve that one. All right. And then here they're saying what? The roots of a quadratic equation, this with differ by 2. What is the value of k and the roots of this question? Hint, let the roots be alpha and yeah. Okay, so I think I'll start the topic for the alpha and beta in the next video. Okay, so for now I'll end here. Have a blessed night and God bless you.